Good day to everyone. So let us continue our lesson for machine design. But first, let us first review the course learning outcomes of this subject. Number 1, understand the principles in the design of machine elements. Number 2, acquire knowledge on how to determine design factor, design stresses, and the application of simple variable and combined stresses to machine parts and elements. And number 3, apply the principles in the design of simple mechanical components. So for this lesson, we will be discussing about design of columns and central loads. When compressive loads are applied to short-thick machine parts, failure occurs by compressive yielding or fracture. So makikita natin dun sa mga una nating lecture, we have discussed failures induced by simple stresses on machine parts, for example, compressive loads. But here in this topic, we will be discussing about another type of failure, which is the type of failure due to instability called buckling. The buckling to be discussed in this chapter is of centrally loaded cylinder members in compression, called columns. A yardstick is a good illustration. The longer and slenderer of the column is, the lower the safe stress that it can stand. So this illustration shows a slender column. Ang ibig sabihin ng slender column, paliit pero mahaba. So pag nilagyan mo siya ng force here sa dulo, dito sa dulo dito at sa dulo dito, may tendency siya na magkaroon ng buckling failure. Ito yung tinatawag natin na buckling. Instead na mag-fail siya due to compressive stress, magbabuckle siya. Kasi kung compressive stress, ang mangyari dyan ay iiksi siya. So in solving this type of stresses and failures, we will be using here a new formula called Euler's equation, which is defined as Fc is equal to pi squared EA divided by the quantity L over K squared, where Fc is the axial concentric load called the critical load that causes the column to be on the point of buckling. So kung babalik tayo dito sa figure na ito, ito yung Fc, the critical load na nag-cause sa kanya para magkaroon ng buckling effect dito sa machine part. E, in this equation, is equal to the modulus of elasticity and tension. For steel, it is equal to 30 million psi. And A, area of cross-section, and L over K is equal to the slenderness ratio. The factor of safety, when incorporated in this formula, it is equal to Fc, or the axial concentric load called the critical load, divided by the F. This is the actual load. The actual load F on the column must be less than Fc if we are to be certain that failures does not occur. So yan dito yung Fc can be written as N times F dito. Pwede mo siyang i-interchange yan. Yung N times F, factor of safety times the actual load, can be replaced here in Fc. And we have also this one term called slenderness ratio, which is equal to L over K. Well, L is the length of the column in inches, and K is the radius of gyration of a cross-sectional area about a centroidal axis. K also is the distance from an axis which, if the entire area of the object were located at that distance, it would result in the same moment of inertia about the axis that the object has. So the value of K can be determined using tables. Halimbawa, for rectangular section, this is your value of K. K sub x, ang subscript niya dito ay x kasi based on centroidal axis. Ang centroidal axis niya yung x na ito. So K sub x is equal to h over square root of 12 for rectangular cross section with height h and width equal to b. While for circular cross section, K sub x, or the radius of gyration, is equal to d divided by 4. So how do we find also the radius of gyration? This is also equal to square root of I over area. Yung I dito ay ito yung moment of inertia about the x-axis. So here, pwede mo rin siyang gamitin ito para makuha mo yung radius of gyration. Euler's equation can be applied to a column with ends fixed in any manner if the length is taken as that between sections of zero bending moment called effective length LE. So yung original equation Euler, makikita nyo wala siya ditong E, di ba? Pi squared EA divided by L over K squared. But this one, meron tayo itong LE kasi ang gagamitin natin ay equivalent length na sinasabi. So ano tong equivalent length? Halimbawa ito, di ba? Ito yung types of columns. Merong column na rounded ends. Ibig sabihin nitong rounded ends, itong end na ito ay pwede siyang gumalaw. Kasi rounded siya. Pwede siyang gumalaw dito sa part na ito at pwede rin siyang gumalaw dito. So hindi siya fixed. So ang LE mo dyan, yung equivalent length is equal to L. Pero kung naman ang dalawang dulo ay fixed, tinatawag natin na fixed ends, ang equivalent length mo ay L over 2. Okay? So, hindi siya yung total na length. Pag ang isang round, one end fixed, the other is rounded, ito, parang combination ng A and B. So, ang isa ay round, ang isa ay fixed. So, ang equation naman nito, ang equivalent length ay 0.07 times L. And the other one is one end fixed and the other is free. Ito naman ay parehas nitong B sa C dito. Ang pagkakaiba lang dito, ito ay free end. So, iba rin yan dito. Ito, hindi siya free. Round lang siya, gumagalaw siya pero hindi siya free. Samantalang ito ay free. It can sway left or right. So, ang LE mo dyan is equal to 2L. So, yan ang gagamitin natin dito sa Euler's equation. Then, Euler's equation has its restriction. This is if LE over K is greater than about 120. So, pag dinivide mo yung effective length divided by the radius of gyration of the section, then dapat greater than 120. Itong Euler's equation ang gagamitin mo sa pag-solve ng problem, pag-design. Kasi meron tayong isa pang equation, yung tinatawag na Johnson's equation. This is for short columns. So, ang sabi dito, FC is equal to SY times A multiplied by 1 minus SY times the quantity LE over K squared divided by 4 pi squared E. So, ito naman ang gagamitin mo if LE over K is greater than 30 but less than 120. Pag greater than 120, ang gagamitin mo yung Euler's equation. So, ano naman yung SE dito? Equivalent stress that indicates the degree of safety for the load F. So, may relationship siya. Kanina, meron tayong factor of safety. Factor of safety is the critical load divided by actual load. So, this also equal to yield strength divided by SE or the equivalent stress. So, itong equation na ito ay mahalaga to sa solution. Meron tayong transition point between long and intermediate column. So, sabi natin yung long column for Euler's equation, ito naman ay short column, Johnson's equation. So, meron tayong transition point na equation between these two. Yung LE over K is equal to the quantity 2 pi squared E divided by SY raised to 1/2 or square root of this term. So, kung titingnan natin dun sa table, so meron tayong graph which shows the difference between Euler and Johnson. So, halimbawa, si Euler, sa steel, ito yung graph niya. So, this is stress in KSI, critical load, divided by cross-sectional area. Ito yan. At ito naman lang dito ay yung LE over K, slenderness ratio. So, for Euler steel, ito yung graph niya. So meron pang mga iba-ibang klaseng graph. Halimbawa sa 8742 OQT 1200, ito yung graph niya. Halimbawa 1137 OQT 110, ito naman yung graph niya. And so on. So si Johnson, ang pinaka-baba niyang graph ay itong sa 1015, which is, kung titingnan nyo sa table, itong 1015 ay low carbon steel ito. So ito naman ay yung mga high carbon steel. So, makita nyo dito si Johnson at LA over K equal to 120, meron siyang nag-meet yung dalawang graph. Kung gagamit ka kay Euler, gagamit ka nitong greater than 120, at kung kay Johnson naman, for safe purposes, dito ka gagamit sa 120 to 30. Kaya meron tayong 30 dun. So, in transition, dito sa point TD, this is 120, you can use either Euler or Johnson. There is also the third one, the second formula. If one assumes that the load F has an eccentricity E. So, saan gagamit itong second formula? Kung meron siyang eccentricity E. So, hindi siya central load. Tulad nitong figure. Right? So, that the material is elastic and the deflection is small, the consequent theoretical equation is the so-called second formula. If the limiting load is that corresponding to Sy, we have this formula. Sy is equal to Fc over A multiplied by the quantity 1 plus EC. Ano tong EC ito? Itong E, itong distance ng eccentricity. So, nandito naman sa figure. Ito ang dinidesign natin ay itong section na ito. So, paano natin i-design yan? Kasi ang load niya hindi sa central, eccentric siya. So, kaya meron tayo ditong factor na E, distance yan. Ito rin yung C, tulad rin itong C, distance rin yan. Okay? Usually, pag symmetrical as cross-section, ang C is equal to 1/2 of this distance. 1/2 of thickness, 1/2 of the diameter. Ganyan. Yung C. K is the same. This is the second. LA is the same. FC is the same, the critical load. E, modulus of elasticity in tension. And A, this is your area. So, mahaba lang yung equation. Pero, defined naman siya. Pares lang nung previous formula. So, if we apply the factor of safety on this equation, right, makikita nyo, ito na yung magiging formula niya. So, FC is equal to NF. We have defined that in the previous slides. So, papalitan mo lang yung FC na mga NF if you want to apply the factor of safety. Dito, FC is equal to NF. So, ganun lang. And the others are the same. So, let us take an example here. A 25-inch long round steel rod made of structural steel, AISI C1020, as ruled, is to be used as a column, centrally loaded with 10 kips, where N is equal to 3, the factor of safety. Determine the diameter if the column has A, rounded ends, B, one end fixed, the other is free, C, the same as A, and B, except that the material is AISI 8640, OQT 1000 degrees Fahrenheit. Is there any advantage in using this material rather than structural steel? So we have here, in this figure, ito yung nasa letter A, rounded ends. So we have here LE is equal to L. So for AISI C1020 as ruled, we have SY is equal to 48 KSI. So C1020, nandito yan sa table 87. As ruled, yield strength is 48 KSI. SY. So F is given 10 kips or 10,000 pounds, 10 kilopounds. Factor of safety is equal to 3. So if we draw that in the illustration, it looks like this one. Ito yung steel rod. So nandito yung force acting on this steel rod. So but these ends here, they are not fixed. Ang ends niya ay parehas nito. So itong 10 kips na ito yung 10 kips dito sa dulong ito, at ito yan din yung opposite end niya. So first, we have to make a trial and error here. So consider first JB Johnson formula. So pag hindi natin nakuha sa JB Johnson, kukunin natin yung Euler equation. Ang hinahanap natin dito ay masatisfy natin yung condition using this equation. Pag nasatisfy siya, then tama yung ginamit nating formula. So LE is equal to L equal to 25 inch. So kaya nang sabi ko LE is equal to L 25 inch. So ang formula ng Johnson is FC is equal to NF, nandito yung SYA, L over K squared, SY 4 pi squared E. So knowing the value of A is equal to pi D squared over 4 kasi circular cross section siya, given naman yan sa problem, long round steel. So ang K dito is D over 4 and E is 30 times 10 raised to 3 KSI or 30 times 10 raised to 6 PSI. So cube yan kasi KSI siya. Kung PSI ito, 6 yan. Hindi siya 3. So isa-substitute lang natin yan dito sa formula. So ganun lang kasimple. Hindi man masyado mahirap. Tatandaan nyo lang yung formula. Gagamitin nyo lang yung tamang formula. So continuation. So we substitute the given and determined values. N is equal to 3, F is 10 kips, SY is 48, KSI, this is your A, pi D squared over 4, then 1, SY is 48 uli, LE 25 inches, K is D over 4 squared, divided by 4 pi squared 30 times 10 raised to 3, K is I. This is E. So, in solving this equation, you have to be careful with the units. Right? Kasi pag nagkamali kayo sa units nito, medyo mali din yung answer nyo. Dapat magkaroon kayo ng consistency of units. Dapat kung naka-KSI, kung naka-1,000, lahat dapat naka-1,000. Para hindi ka mag-cancel ng maling number. So, if we simplify this one, this is equal to 30, 12 pi D squared, 1 minus 4 over pi squared D squared. Yan. Simplify the numbers and the variable D. So, nakikita nyo, ang ano na lang dito yung diameter. So, if you have your calculator, ang pi is 3.1416. So, we can compute D is equal to 1.096 inches. Or D is equal to 116 inch or 1.0625 inches. Then, we will check the slenderness ratio, which is equal to LE over K 25 over 1.0625 over 4. So, ito yung LE, 25 inches. Ito yun naman yung value ng K. D divided by 4. Diba? D, diameter, 1.0625 divided by 4. So, we have here 94. Less than 120. So, that means that is okay. Kasi sabi natin, ang Johnson's formula, okay, Johnson's formula, dapat LE over K is less than 120 but greater than 30. So, kung masatisfy natin ito for that material, so okay yung design natin. We can use the diameter equal to 1.0625 inch. So, kung nag-greater yan, 120, then you try the Euler's equation. Number 2, ang sabi doon, if one end is free and the other is fixed, so we will use this one. LE is equal to 2L. 2 times 25 is equal to 50 inches. Ito yung equivalent length natin. So, gamitin naman natin yung Euler's equation, which states that FC is equal to NF equal to pi squared EA divided by LE over K squared. So, by substitution, this is your factor of safety, 10 kips, your F, yung actual load, pi squared 30 times 10 raised to 3 KSI E. This is your area, pi d squared divided by 4. Ito yan. Then, LA over K. So, ang effective length is 50. Ang K, the radius of gyration is D divided by 4 squared. Then, using your calculator, we find the diameter equal to 1.507 or say 1 and 1/2 inch. Then, we check for the slenderness ratio. LE over K. So, we have the effective length 50 divided by K, the formula D divided by 4, diameter divided by 4. This is our diameter, the computed diameter, 1.5 divided by 4. Then we have here 133, which is greater than 120. So, that means using Euler's equation and finding the value of D equal to 1.5 inch, this solution is okay. Just like this one, using Johnson's equation and finding the diameter equal to 1.0625 inch, then we have checked for slenderness ratio. We got the value of 94, which is less than 120. Then, using this equation, satisfies this restriction, the slenderness ratio. So, that is okay. So, C, we will use another material. We try another material. The given material is AISI 8640. OQT 1000 degrees Fahrenheit. So, upon looking at table 87, we have here AISI 8640, this one, OQT 1000, we have SY equal to 150. Ito yan. Okay, ito yung SUSS, this is your SY, 150. So, kung babalik tayo dito sa, yan. Itong first column is U, SS, the third column is SY. So, yan, SY is equal to 150. So, here, tingnan natin yung intermediate. Diba, meron tayong formulang sinabi, yung transition point between long and intermediate column, which is LE over K equal to this formula. So, using this material, AISI 8640, we can compute for the transition point between the Johnson and the Euler's equation, which is, ito nga sabi ko sa inyo, yung formulang ito, transition point. So, ito ang ginamit dyan sa dito. So, we have here, by substitution of E and SY to this equation, so, it is computed that LE over K, the slenderness ratio is equal to 62.83. So, ito yung pagitan ng dalawa. So, pag gumamit tayo ng Johnson, dapat less than 62.83 ang makuha natin. Kung gumamit naman tayo ng Euler, dapat greater than 62.83. So, kung anong tumama dun, yun yung tamang dimension. So, consider first Johnson. Right? So, sana naiintindihan nyo. So, we have LE equal to 25. So, by substitution again, the formula is shown in your video. Okay, I will not read again the formula. So, by substitution, N is equal to 3. F, the load is 10 kips. SY is equal to 150 KSI. Then, this is the area, pi d squared over 4, area for circle. And again, this is also SY, 150 KSI. This is L over K. L is equal to 25 kasi ang sinosolve natin yung for letter A. Just like letter A, 25 inch ang effective length. Then, the radius of gyration K is equal to D over 4. And E, 30 times 10 raised to 3 KSI. So, we have here the diameter by simplifying. You can simplify this manually, and if you have your calculator, you can compute this using your calculator immediately. So, we have diameter is equal to 1.23 inch. So, say, for standard purposes, let us use 1.25. inch. Then we will use this D 1.25 to check the slenderness ratio LA over K here. So we have here 25, effective length divided by K, the diameter divided by 4. That is the formula for K. So 1.25 yung diameter divided by 4. So we have here, this is equal to 80, which is greater than 62.83. So dapat ang makuha natin dito ay less than. Kasi ito yung transition point. Ito yung parang 120 kanina. So kinompute natin yung transition point ng ng dalawang equation, 62.83 using the formula. Pero pag gamit tayo ng Johnson equation, makukuha natin ang LA over K is equal to 80. So we will try to use Euler's equation instead. So this is your Euler's equation again. So by substitution, this is your N, factor of safety, F is equal to 10 kips. This is your A, this is your area, pi d squared over 4, LE, 25, K, d over 4, squared. So, using again your calculator, we will find out that d is equal to 1.0657. So, say 1 and 16 inches. So, we have here LE over K, to check the slenderness ratio. LE over K is equal to 25 divided by 1.0625, the diameter, over 4. This is your radius of gyration. So, we arrive at 94, which is greater than 62.3. So, this is okay kasi ang Euler's equation dapat greater than the transition point na 62.83. Doon kasi sa steel, ang transition point niya is 120. Dito, compute natin for this particular material, AISI 8640 o QT 1000 degrees Fahrenheit. So, nakakompute tayo ng 62.83 na transition point. So, if we use Euler's equation, dapat greater than. So, since nakakuha tayo ng greater than, so using Euler's equation is the preferable solution. So, ano ang gagamitin nating dimension D? Ito na, 1.0625. Hindi yung ito, hindi yan, hindi yung 1.25. So, let us continue our solution for B. So, kanina, this is for A. Okay? LE is equal to 25 inch. So, if LE is equal to 50 inches naman, as in the case of B, so, first we have to try for Euler's equation. So, again, Euler's equation is this one. So, we have to substitute this one, N, 3, factor of safety, F, 10 kips, E is equal to 30 times 10 raised to 3, K is I, area, cross-sectional area is pi d squared over 4, effective length, this one, 50, and D over 4 is the value of K for circular cross-section. And solving for D, we have 1.507 inches. Then, let us check for the slenderness ratio. So, Euler's equation ito. So, LE is equal to 50, K is 1.5 divided by 4. This is your diameter divided by 4. And we have here 133, which is greater than the transition point 62.83. So, for B, we can use 1.5 inch. Right? So, kung makikita nyo dito, pag kinompare natin yung ang una nating na-solve for A, so pag kinompare natin yung mga na-solve nating value, ang sabi kasi dito, is there any advantage in using this material rather than structural steel? So yung structural steel na sinasabi, ito yung AISI C1020. Okay. So, kukumpare natin, ano nakuha natin dito sa A? Rounded ends. So, we have computed here 1.0625. So, ito yung structural steel. So, using naman this one, AISI 8640, ang na-compute din natin ay 1.0625 din. So, parehas lang. At using L is equal to 50 here, ang na-compute natin ay 1.5. This 1.5 here is using this material AISI 8640. So kung i-check natin dun sa C1020, ang na-compute naman natin sa B ay parehas din 1.5 inch. So ano ang ibig sabihin? There is no advantage. Kasi using AISI C1020, parehas lang yung nakuha natin na dimension, yung diameter, kung ang gamitin natin ay 8640. Okay, so there is no difference. So yan ang ating unang example dito sa topic na ito. Meron pang iba-ibang application ito sa mga susunod na mga discussions natin. Dadaanan ulit natin itong ganitong mga theory, mga formula. So yan muna para sa topic na ito. Salamat.